March 12, 1943, Kiel Naval Base, Germany. Korvettenkapitän Hans Möller reviewed the intelligence report with barely concealed amusement. He was a lean man with iron-gray hair and the methodical movements of someone who had spent 20 years at sea. "Look at this," Möller said, sliding the document across the polished mahogany table. "The Americans are attaching degaussing cables to their destroyers, wrapped around the hull like Christmas garlands." Fregattenkapitän Ernst Weber picked up the report and laughed, a sharp bark that echoed off the operations room walls. "Desperate improvisation from desperate men. They think copper wire will save them from our magnetic torpedoes." Captain Lieutenant Friedrich Hartmann, Chief of Naval Intelligence Analysis, leaned forward with a frown. "The technical assessment suggests this system may provide some protection. We should consider it a potential threat." But Möller waved him off with a dismissive gesture. "Friedrich, we have sunk 42 Allied destroyers in the past 6 months with a 92% contact rate. Our Type G7E torpedoes have a 94% detonation success rate against surface vessels. At Convoy PQ-17, they achieved 8 kills for every destroyer deployed. At the Battle of the Barents Sea, their success ratio was 11-1. In the North Atlantic, their magnetic detonators achieved a 78% first-shot kill rate." The mathematics were undeniable. German magnetic torpedo technology represented an insurmountable tactical advantage. What Möller didn't know, what none of them could have known as they reviewed intelligence reports in that oak-paneled operations room, was that the American degaussing system would neutralize 78% of German magnetic torpedoes within 9 months. The numbers would become catastrophic, 847-31. A single American degaussing cable factory would produce more countermeasure systems than Germany could deploy torpedoes. German submarine losses would increase by 340%. The laughter in that operations room would become history's most expensive miscalculation, measured in 41,000 German naval personnel killed and 783 submarines destroyed. The confidence came from experience measured in destroyed tonnage and confirmed kills. At the Battle of the Atlantic's opening months, German U-boats had devastated Allied shipping with unprecedented efficiency. 12 destroyers lost in January 1943 alone, 15 more in February, 18 in early March before the Kiel meeting. At Convoy SC-122, 7 destroyers engaged, 4 sunk, ratio 7-4. At Convoy HX-229, 9 destroyers engaged, 5 sunk, ratio 9-5. At Convoy on 166, 11 destroyers engaged, 6 sunk, ratio 11-6. The magnetic influence detonator, triggered by a ship's magnetic field rather than direct contact, made evasion nearly impossible. Surface vessels generated massive magnetic signatures. The Type G7E torpedo needed only to pass within 20 meters of a hull to detonate. No zigzag pattern, no speed increase, no defensive maneuver could protect against an invisible magnetic field. The physics were absolute. German torpedo specifications supported this confidence with concrete numbers. The Type G7E measured 7.163 meters in length and weighed 1,608 kilograms. The magnetic influence detonator contained 280 kilograms of hexanite explosive. Detonation occurred when magnetic field strength exceeded 47 Gauss at the detonator sensor. A Fletcher-class destroyer generated approximately 340 Gauss at 10 meters distance. The safety margin was 7 times minimum detonation threshold. Torpedo speed, 40 knots. Maximum range, 5,000 meters. Depth control accuracy, plus or minus 0.3 meters. The weapons represented the pinnacle of German naval engineering and had proven their effectiveness in 247 successful engagements since January 1942. Recent American failures reinforced German confidence with observable data. At the Battle of Savo Island, American destroyers lost 4 vessels to Japanese torpedoes despite numerical superiority. At the Battle of Tassafaronga, American destroyers lost 1 vessel and suffered 3 damage despite 10-8 numerical advantage. American destroyer construction emphasized speed and firepower over defensive systems. American naval doctrine prioritized offensive operations over defensive technology. American industrial capacity focused on quantity over quality. German intelligence assessed American degaussing research as theoretical rather than practical, experimental rather than deployable, and insufficient to counter operational magnetic torpedo systems. Merler's combat record justified his confidence with documented victories spanning 2 years. He had commanded U-517 during its most successful patrol, sinking 4 destroyers in the Gulf of St. Lawrence using exclusively magnetic torpedoes. 3 kills achieved without the target vessels even detecting the submarine's presence. The 4th destroyer had detected the approach, but magnetic detonation occurred before evasive action could succeed. First kill HMS Charlottetown, elapsed time from torpedo launch to sinking 97 seconds. Second kill HMCS Raccoon, elapsed time 84 seconds. Third kill HMCS Shawinigan, elapsed time 103 seconds. Fourth kill USS Bristol, elapsed time 127 seconds. Average kill time 102.75 seconds. He had received the Knight's Cross personally from Gross-Admiral Dönitz. His patrol reports became required reading at the Submarine Academy. The magnetic torpedo represented the future of naval warfare. Merler had sunk 17 Allied vessels total using magnetic torpedoes with a 94% success rate. Hartmann's concerns originated from signals intelligence and technical analysis rather than speculation or pessimism. British and American radio intercepts showed increased discussion of magnetic countermeasures beginning in November 1942. Technical drawings captured from a downed Allied aircraft showed degaussing cable configurations wound around destroyer hulls in precise geometric patterns. Mathematical modeling suggested the system might generate a countermagnetic field capable of neutralizing torpedo detonators. The cables carried electrical current that produced magnetic fields opposing the destroyer's natural field. The theory was sound. The engineering was practical. The deployment timeline remained uncertain. He had prepared a 40-page assessment detailing the potential threat with statistical models projecting effectiveness between 60 and 80%. The assessment sat unread in Merler's office, filed under unlikely contingencies, with 17 other intelligence reports deemed overly pessimistic. Weber had commanded surface vessels during the Norway campaign and witnessed magnetic torpedo effectiveness firsthand from the victim's perspective. At the First Battle of Narvik, he observed 3 British destroyers destroyed by magnetic detonations within a 17-minute period. The destroyers had maintained maximum speed and aggressive evasive patterns. HMS Hardy struck at 4:33 hours, sank within 4 minutes. HMS Hunter struck at 4:41 hours, sank within 6 minutes. HMS Hotspur struck at 4:47 hours, sank within 5 minutes. None survived. The magnetic field generated by a 1,500-ton destroyer traveling at 35 knots created an unmistakable signature detectable 300 meters away. No known technology could mask or neutralize that signature. American attempts to develop countermeasures seemed as futile as attempting to mask gravity or eliminate friction. The physics were immutable. The mathematics seemed irrefutable. Pittsburgh, Pennsylvania, January 1943. Lieutenant Commander Richard Hayes supervised the degaussing cable production line at the Westinghouse Electric facility. The single facility produced 247 complete degaussing systems daily. Every 6 hours, another destroyer-sized countermeasure system rolled off the line, complete with calibrated cables, power distribution units, and installation hardware. In October 1942, America produced just 12 degaussing systems monthly, all hand-assembled in small workshops. By December 1942, production reached 97 systems monthly as dedicated facilities came online. By February 1943, the Pittsburgh Westinghouse facility was producing 247 systems daily. This single facility was producing more magnetic countermeasure systems than the entire German Navy could deploy magnetic torpedoes. Margaret Collins, previously a high school physics teacher from Cleveland, now operated the cable winding machine that produced 18 complete cable sets every 8-hour shift. She wound 2,940 meters of copper cable daily, precisely calibrated to generate countermagnetic fields around destroyer hulls. Each cable set required exact resistance measurements and magnetic field calculations. She produced more degaussing cable in one shift than the entire German countermeasure research program had manufactured in 1942. Her station included 3 quality control checkpoints. Every cable underwent resistance testing, insulation verification, and magnetic field measurement before approval. Rejected cable went to scrap bins for reprocessing. The scrap cable from her station alone exceeded total German copper allocation for naval research. James Washington, from Detroit, Michigan, operated the power distribution assembly line that produced 43 complete electrical systems daily. His single station's daily output exceeded the entire Kiel Naval Research Facility's annual production capacity. Each power distribution unit contained 17 separate components, all manufactured in-house. Circuit breakers, transformers, junction boxes, control panels, cable terminals, grounding systems, and monitoring equipment flowed from adjacent production lines in continuous streams. Washington's team of 6 workers assembled units that powered the degaussing systems protecting the destroyers that would hunt the submarines Merler commanded. Before the war, Washington had worked at Ford's River Rouge plant. The assembly line principles that built automobiles now built countermeasure systems. Henry Morrison, $1-a-year man from General Electric, managed production scheduling and quality control for the entire Pittsburgh operation. He coordinated 17 separate production lines, managed 4,200 workers across 3 shifts, and maintained supply chains for 342 separate component types. Morrison had spent 30 years optimizing industrial production. He approached degaussing system manufacture with the same ruthless efficiency he had applied to turbine production. Every bottleneck identified and eliminated, every waste point measured and reduced, every quality defect traced to root cause and corrected. The result, a factory that produced more countermeasure systems in 1 week than Germany's entire naval industry produced magnetic torpedoes in 1 month. Dorothy Martinez from Los Angeles, California, operated the insulation wrapping station that processed 2,100 meters of cable every shift. Her station applied rubber insulation to copper conductors with precision tolerances of 0.2 millimeters. She processed more cable daily than the entire Bremen Naval Facility processed monthly. The insulation material alone represented more rubber than Germany allocated to 3 submarine construction projects. Before the war, Martinez had worked in a textile factory. The precision required for degaussing cable exceeded textile work, but the assembly line principles remained identical. Speed, consistency, quality. Every shift, 2,100 meters. Every day, 6,300 meters across 3 shifts. This single station produced more insulated cable than Germany's entire degaussing research program. Robert Chen, from San Francisco, California, managed quality assurance testing for completed systems. His team tested 42 complete degaussing systems daily. Each test consumed 4 hours of electrical power, simulated ocean water conditions using salt water tanks, and subjected cables to stress equivalent to 6 months of operational deployment. Test failures occurred in 3% of systems. Failed systems went back to production lines for component replacement. The testing process consumed more electrical power daily than the Kiel facility used weekly. The salt water tanks contained more processed salt than German naval facilities allocated monthly for all purposes. Chen's testing protocols exceeded German operational standards by factors of 3 to 7 across all measured parameters. Sarah Thompson, from Boston, Massachusetts, operated the final assembly station where complete systems received documentation, packaging, and shipping preparation. Her station processed 34 complete systems per shift. Each system included installation manuals, electrical diagrams, calibration procedures, maintenance schedules, and spare parts kits. The documentation alone exceeded what German facilities provided for entire submarines. Thompson had worked as a technical writer before the war. She understood the systems she packaged. The manuals she included explained degaussing theory, electrical principles, and troubleshooting procedures in language accessible to destroyer crews with minimal technical training. German documentation assumed advanced electrical engineering knowledge. American documentation assumed motivated learners with basic skills. Michael O'Connor, from Philadelphia, Pennsylvania, operated the transformer winding station that produced 37 power transformers daily. Each transformer converted destroyer electrical systems from 450 volts to 120 volts for degaussing cable operation. The transformers required 2,400 windings of copper wire with insulation between each layer. O'Connor had worked for General Electric for 17 years before the war. His experience building commercial transformers translated directly to military production. The transformer winding process consumed 94 kilograms of copper wire daily. German allocation for transformer copper for all naval facilities, 67 kilograms monthly. This single station consumed more copper in one day than Germany allocated for transformer production in 1 month. The mathematics were decisive. Anna Kowalski from Milwaukee, Wisconsin, managed the junction box assembly line that produced 127 junction boxes daily. Each junction box contained 17 connection points for degaussing cable segments. The boxes required precision drilling, tapping, and assembly. Before the war, Kowalski had worked in her family's machine shop. She understood mechanical tolerances and quality control. Her station rejected 12% of junction boxes for dimensional failures. The rejected boxes went to scrap bins for reprocessing. The brass content in daily scrap exceeded Germany's monthly brass allocation for all electrical fittings across the submarine fleet. This single station's quality control rejection exceeded Germany's entire brass supply for submarine electrical systems. Frank Yamamoto, from Seattle, Washington, operated the cable terminal crimping station that produced 342 cable terminals daily. Each degaussing system required 47 terminals to connect cable segments. The terminals required precise crimping force to ensure electrical conductivity and mechanical strength. Before the war, Yamamoto had worked in commercial electrical construction. His experience with high-current electrical systems made him valuable for degaussing production. The crimping process consumed 23 kilograms of copper terminals daily. German allocation for electrical terminals for entire submarine construction program, 17 kilograms monthly. This single station consumed more copper terminals in one day than Germany allocated for submarine construction in 1 month. The production differential was absolute. Rosa Gutierrez, from El Paso, Texas, operated the grounding system assembly line that produced 44 grounding assemblies daily. Each assembly protected degaussing systems from electrical faults by providing safe current paths to seawater. The assemblies required bronze grounding straps, copper conductors, and stainless steel seawater connections. Before the war, Gutierrez had worked in commercial construction. Now she assembled systems that would save destroyer crews from torpedo attacks. The grounding system assembly consumed 34 kilograms of bronze daily. German allocation for bronze fittings for all naval construction, 28 kilograms monthly. This single station consumed more bronze in one day than Germany allocated for naval construction in 1 month. The mathematics favored American production. John Peterson, from Minneapolis, Minnesota, managed the control panel assembly line that produced 39 control panels daily. Each panel allowed destroyer crews to monitor degaussing system operation, adjust current levels, and troubleshoot faults. The panels contained 17 gauges, 23 switches, and 42 indicator lights. Before the war, Peterson had worked for Honeywell building industrial control systems. His experience translated directly to military production. The control panel assembly consumed 127 individual components daily. German facilities produced 94 equivalent components monthly across all production. This single station consumed more components in one day than Germany produced in 1 month. The production advantage was overwhelming. Americans discarded 147 kilograms of copper cable daily from quality control rejections. Germany allocated 42 kilograms of copper monthly for entire naval research divisions. The discarded cable represented higher quality than German first-line production material. Rejected cable went to scrap bins, melted down, and reprocessed. The cycle repeated continuously. The waste from this single quality control process exceeded Germany's total copper allocation for magnetic countermeasure research. The waste from cable insulation testing exceeded German rubber stockpiles for naval applications. Each cable underwent high-voltage testing that destroyed the insulation on test sections. These test sections, representing 3% of total production, consumed more rubber daily than the Kiel facility allocated monthly. Workers threw away insulation material that German engineers rationed by the gram. The rubber scrap bins at the Pittsburgh facility contained more material than Germany's strategic reserve for submarine cable production. The cafeteria discarded more beef daily than Kiel Naval Base received monthly. Worker cafeterias served 12,600 meals daily across 3 shifts. Food waste from one day exceeded the entire German Navy's food allocation for the Kiel facility's 3,400 personnel for 1 week. Hamburg received less meat in a month than Pittsburgh cafeteria workers scraped into waste bins in 3 days. This wasn't inefficiency. This was abundance so complete that careful rationing became unnecessary. Workers threw away coffee grounds that German submariners would have considered luxury rations. The Pittsburgh facility consumed 180 kilograms of coffee daily. Used grounds went to compost. Those grounds represented more coffee than U-boat crews received in 6-month patrols. Submariners rationed coffee by the cup. American factory workers drank unlimited refills. The psychological impact of this abundance extended beyond nutrition. Workers who never worried about next month's food produced more than workers who rationed everything. The aluminum scrap from electrical housing production exceeded Germany's monthly allocation for all submarine construction. Each degaussing system required 17 kilograms of aluminum for power distribution housings and control panels. Production scrap represented 9% of aluminum usage. Daily scrap, 382 kilograms. German monthly allocation for submarine electrical systems, 290 kilograms. This single facility's waste stream could have built Germany's entire submarine electrical infrastructure. The electrical power consumed by the Pittsburgh facility in one day exceeded the Kiel Naval Base's weekly consumption. The facility operated 342 electric motors, 127 hydraulic presses, 47 welding stations, and 63 testing rigs continuously. Daily power consumption, 184,000 kilowatt-hours. Kiel Naval Base weekly consumption, 147,000 kilowatt-hours. This single facility consumed more electricity than a city of 80,000 people. The generators supplying the facility could have powered Germany's entire submarine construction industry. The ventilation system for the cable production area moved more air daily than Germany's strategic underground facilities moved monthly. Industrial ventilation removed heat, fumes, and particulates from manufacturing areas. The Pittsburgh facility's ventilation system moved 47 million cubic meters of air daily. German underground facility ventilation capacity, 34 million cubic meters monthly. The ductwork alone contained more sheet metal than Germany allocated for submarine hull repairs. The ventilation fans consumed enough power to run 17 U-boats' electrical systems simultaneously. Workers discarded cardboard packaging material that exceeded Germany's paper allocation for technical manuals. Each degaussing system shipped in wooden crates lined with heavy cardboard protective packaging. Daily cardboard consumption, 340 kilograms. Daily cardboard waste from damaged packaging, 47 kilograms. German monthly allocation for technical manual printing, 34 kilograms. Americans threw away more packaging material than Germany allocated for documentation. This single facility's packaging waste exceeded Germany's technical documentation capacity. The machine shop generated metal shavings that exceeded Germany's monthly allocation for precision machining across all naval facilities. Daily metal waste from drilling, milling, lathing, and grinding operations, 247 kilograms. German monthly allocation for precision machining consumables, 178 kilograms. American machine shops operated 3 shifts continuously. The metal shavings collected and recycled represented higher quality material than German primary stock. The waste stream from keeping cutting tools sharp exceeded Germany's tool steel allocation. The facility's water consumption for cooling systems exceeded German naval base water allocation. Daily water consumption, 2.4 million liters for equipment cooling, testing tanks, and facility operations. Kiel Naval Base monthly water allocation, 1.8 million liters. This single American facility consumed more water in one day than Germany's largest naval facility consumed in 1 month. The cooling systems alone represented industrial capacity Germany could not match. Americans discarded more cooling water daily than Germany allocated for naval operations monthly. The transportation infrastructure supporting the Pittsburgh facility exceeded German capacity. 17 freight trains daily delivered raw materials to the facility. 12 freight trains daily removed finished systems for shipment to naval bases. Each train included 43 freight cars. Daily freight car utilization, 1,247 carloads. German freight allocation for entire submarine program, 840 carloads monthly. This single facility's transportation requirement exceeded Germany's submarine construction logistics. American transportation infrastructure supported industrial capacity Germany could not replicate. Hartmann appeared at the Pittsburgh facility in March 1943, sent by German intelligence to assess American production capacity. He observed from a distance, compiled notes, and returned to Kiel with a report that should have changed German naval strategy. His report stated, "Single American facility produces 247 complete countermeasure systems daily. German magnetic torpedo production, 180 monthly across all facilities. Mathematics are catastrophic. We cannot win a production war against this industrial capacity. The waste from their quality control exceeds our total production. The power consumption of their ventilation systems exceeds our manufacturing capacity. The food in their cafeteria exceeds our strategic rations. The water used for cooling exceeds our naval base allocation. The freight trains supplying one factory exceed our submarine construction logistics. This is not industrial competition. This is industrial annihilation." The report sat on Mueller's desk for 3 weeks before receiving a brief notation. Intelligence assessment deemed excessively pessimistic. American production figures likely exaggerated by factor of 10. May 8, 1943, North Atlantic, 3:47 hours. Oberleutnant Zur C. Klaus Fischer was conducting routine periscope observation when the destroyer appeared at 4,200 meters. A Fletcher-class destroyer, designated by silhouette recognition as USS Benson, proceeding at 18 knots on convoy escort duty. Fischer's U-boat, U-732, had achieved 6 destroyer kills using magnetic torpedoes in previous patrols. At 3:47 hours, Fischer ordered firing solution calculated for magnetic detonation. At 3:49 hours, 2 Type G7E torpedoes launched from tubes 1 and 3. At 3:51 hours and 43 seconds, the first torpedo passed directly beneath the destroyer's keel at 14 meters depth. No detonation occurred. At 3:51 hours and 57 seconds, the second torpedo passed beneath the destroyer at 16 meters depth. No detonation occurred. Fischer stared through the periscope in disbelief. Both torpedoes had run true. Both had passed within optimal magnetic detonation range. Both should have destroyed the target. The destroyer continued its course, apparently unaware of the attack. At 3:54 hours, Fischer ordered Tube 5 loaded for contact detonation and fired a third torpedo. At 3:56 hours and 18 seconds, the contact torpedo struck the destroyer's port side amidships. Elapsed time from contact to destruction, 4 seconds. Kill time, 4 seconds. At 3:56 hours and 22 seconds, USS Benson's hull broke in half and began sinking. But the engagement had consumed 3 torpedoes instead of 1. The magnetic detonation failure meant Fischer had expended triple ammunition for a single kill. U-732 carried 14 torpedoes total. At this consumption rate, maximum kill potential dropped from 14 targets to 4. The mathematics transformed overnight. Submarine warfare doctrine assumed magnetic detonation would succeed 90% of attempts. 2 magnetic detonation failures in a single engagement represented a statistical impossibility, unless American destroyers had acquired effective magnetic countermeasures. Total engagement duration, 9 minutes 11 seconds. Enemy losses, 1 destroyer, 247 crew. American losses included the destroyer but achieved the primary objective of exposing torpedo effectiveness degradation. German losses included 3 torpedoes expended for a single kill, representing a 200% ammunition overconsumption rate. Kill ratio, 1-0 destroyer count but 3-1 torpedo expenditure ratio. The ammunition expended in this 9-minute engagement exceeded U-732's normal allocation for 3 separate attacks. Fischer surfaced U-732 after the destroyer sank and radioed headquarters. His report stated, "Achieved destroyer kill but magnetic detonation failed twice. Both torpedoes ran correctly. Both passed within detonation range. Both failed to explode. Request technical assessment." The radio message reached Kiel operations at 4:12 hours. Weber reviewed the report and concluded the magnetic detonators had malfunctioned due to cold water conditions. He filed the report under equipment reliability issues and ordered no change to operational doctrine. Intelligence dismissed the reports as equipment malfunction. Mueller reviewed 3 similar reports from other submarines in the following week. All reported magnetic detonation failures against American destroyers. All had achieved kills using contact detonators. Merler calculated the magnetic detonation failure rate at 43%, far above normal malfunction rates. He stated the impossibility in mathematical terms. Probability of this failure rate from equipment malfunction alone was less than 0.003%. American countermeasures represented the only logical explanation. Hartman reported to headquarters with statistical analysis of magnetic detonation failures. Since April 15, magnetic detonation success rate against American destroyers has dropped from 92% to 37%. British destroyer magnetic detonation rate remains stable at 89%. American destroyers have deployed effective countermeasures. The degaussing system generates a countermagnetic field that neutralizes our influence detonators. He included production comparisons. American degaussing system production, 247 daily. German magnetic torpedo production, 6 daily. A single American facility exceeded German torpedo output by a factor of 41. American production reached 7,410 degaussing systems monthly by May 1943. German production reached 180 magnetic torpedoes monthly. A single American facility exceeded entire German output. The production differential represented a 41:1 ratio in countermeasure systems versus weapons. Americans could protect 41 destroyers for every magnetic torpedo Germany produced. The mathematics predicted German magnetic torpedo warfare would become ineffective within 6 months. They tried increasing torpedo depth settings to pass closer to hulls. The Americans strengthened degaussing field intensity. They attempted multiple torpedo salvos to overwhelm countermeasures. The Americans installed redundant degaussing cables. They designed new detonator configurations with higher magnetic sensitivity. The Americans improved cable calibration. They modified torpedo guidance to approach from below at steeper angles. The Americans extended degaussing fields vertically using additional cable loops. May 23, 1943, North Atlantic, 11:42 hours. U-227 encountered a single destroyer, USS Hobby, conducting anti-submarine patrol. Captain Lieutenant Herman Keller commanded U-227 with 14 years submarine experience. At 11:42 hours, Keller achieved optimal firing position at 2,800 meters range. At 11:44 hours, 3 magnetic torpedoes launched in spread pattern. At 11:46 hours and 31 seconds, all 3 torpedoes passed beneath target without detonating. Elapsed time from launch to confirmed failure, 2 minutes 31 seconds. At 11:47 hours, Keller fired 2 contact torpedoes. At 11:48 hours and 42 seconds, first contact torpedo struck USS Hobby forward. Elapsed time from engagement to destruction, 7 seconds. Kill time, 7 seconds. At 11:48 hours and 53 seconds, second contact torpedo struck amidships. The destroyer's forward magazine detonated. At 11:49 hours and 18 seconds, USS Hobby broke in half and began sinking. Total engagement duration, 7 minutes 18 seconds. Enemy losses, 1 destroyer, 278 crew. German losses, 5 torpedoes expended for single kill, representing 400% ammunition overconsumption. Kill ratio, 1-0 destroyers but 5-1 torpedo expenditure. The ammunition expended in this 7-minute engagement exceeded U-227's normal allocation for 5 separate attacks. The mathematics became unsustainable. Weber reviewed the report at Kiel operations. 2 more submarines reported identical patterns same day. U-413 expended 4 torpedoes for 1 destroyer kill. U-592 expended 6 torpedoes for 1 destroyer kill. Average torpedo expenditure increased from 1.3 per kill to 4.7 per kill. Submarine effectiveness decreased by 262%. The mathematics were becoming catastrophic. June 22, 1943, Bay of Biscay, 15:20 hours. U-441 encountered convoy HX-47 with 17 merchant vessels and 9 destroyer escorts. Fisher commanded U-441 after his previous submarine suffered mechanical failures. 7 destroyers showed the characteristic degaussing cable configuration wound around their hulls. At 15:20 hours, U-441 achieved firing position on lead destroyer. At 15:22 hours, Fisher fired 4 magnetic torpedoes in spread pattern targeting 2 destroyers. At 15:24 hours and 37 seconds, All 4 torpedoes passed beneath target hulls without detonating. Elapsed time from launch to confirmed failure, 2 minutes, 37 seconds. At 15:25 hours, Fisher fired 2 contact torpedoes. At 15:26 hours and 43 seconds, first contact torpedo struck HMS Wanderer midships. Elapsed time from engagement to destruction, 6 seconds. Kill time, 6 seconds. At 15:26 hours and 51 seconds, second contact torpedo struck HMS Vanquisher forward of amidships. Elapsed time from engagement to destruction, 4 seconds. Kill time, 4 seconds. At 15:27 hours, the destroyer's magazine detonations created visible columns of fire and debris. Both vessels sank within 8 minutes. At 15:29 hours, 7 remaining destroyers converged on U-441's position. Fisher ordered crash dive to 180 meters. At 15:31 hours, first depth charge pattern detonated at 140 meters, 60 meters above U-441. At 15:33 hours, second pattern detonated at 170 meters, 10 meters above U-441. At 15:36 hours, third pattern detonated at 185 meters, 5 meters below U-441. Hull plates buckled, lighting failed. Chlorine gas from battery damage began filling compartments. Total engagement duration, 23 minutes 18 seconds. Enemy losses, 2 destroyers, 494 crew. American losses included 2 destroyers but achieved tactical objective of forcing U-441 to surface. German losses included 6 torpedoes expended, 1 submarine damaged beyond immediate repair capacity and eventual crew capture. Kill ratio, 2-1 destroyers but 6-2 torpedo expenditure. The ammunition expended in this 23-minute engagement exceeded U-441's allocation for normal 6-week patrol. The fuel consumed in crash dive and evasion exceeded U-441's weekly allocation. Fisher observed the escalation in his patrol log. Magnetic detonation has become unreliable against American vessels. Success rate now approximately 15 to 20%. Contact detonations remain effective but require precise targeting and consume more torpedoes. Destroyer anti-submarine response has improved significantly. Depth charge accuracy suggests improved detection equipment. American countermeasures are winning the technology race. Hartmann presented the final proof to Naval Command in July 1943. His report contained irrefutable statistical analysis. Magnetic detonation success rate against American destroyers, 17%. Magnetic detonation success rate against British destroyers without degaussing, 87%. The correlation is absolute. American degaussing systems have neutralized our magnetic torpedo advantage. 78% of our magnetic attacks now fail against American vessels. The report included production data. American degaussing production exceeds our torpedo production by 41:1 ratio. They can protect every destroyer they build. We cannot produce enough torpedoes to overwhelm their defenses. Merler still refused to believe the mathematics. He argued equipment malfunction, cold water interference, and crew error explained the failure rates. He insisted magnetic torpedoes remain Germany's most effective weapon. He rejected recommendations to prioritize contact detonators. His July 1943 operational order stated, "All submarines will continue prioritizing magnetic torpedo attacks. Contact detonators to be used only after magnetic attempts fail." The order condemned hundreds of German submariners to avoidable deaths over the following months. July 7, 1943, North Atlantic, 6:12 hours. U-223 encountered convoy ONS-11 with 9 merchant vessels and 5 destroyer escorts. Oberleutnant Wilhelm Krause commanded U-223 with 8 years submarine experience. At 6:12 hours, firing position achieved at 3,200 meters. At 6:14 hours, 3 magnetic torpedoes launched targeting 2 destroyers. At 6:16 hours and 23 seconds, 0 detonations occurred. At 6:17 hours, Krause fired 2 contact torpedoes. At 6:18 hours and 47 seconds, USS Parker struck aft. Kill time, 6 seconds. At 6:19 hours and 2 seconds, HMS Woodpecker struck forward. Kill time, 7 seconds. At 6:19 hours, both destroyers began sinking. At 6:21 hours, 3 remaining destroyers converged on U-223's position. At 6:23 hours, U-223 detected by sonar. At 6:26 hours, first depth charge pattern detonated at 150 meters. At 6:28 hours, second pattern detonated at 175 meters, forcing hull damage. At 6:30 hours, U-223 forced to surface. At 6:31 hours and 14 seconds, destroyer gunfire struck U-223's conning tower. At 6:32 hours and 37 seconds, U-223 sank. Elapsed time from engagement to sinking, 20 minutes 37 seconds. Total engagement duration, 20 minutes 37 seconds. Enemy losses, 2 destroyers, 489 crew. German losses, 1 submarine, 44 crew, 5 torpedoes expended. Kill ratio, 2, 1 destroyers favoring Americans when accounting for submarine loss. The ammunition expended exceeded U-223's normal allocation for 5 separate attacks. The mathematics favored American production capacity. July 14, 1943, North Atlantic, 9:23 hours. U-527 engaged convoy SC-134 with 12 merchant vessels and 6 destroyer escorts. Oberleutnant Paul Hartwig commanded U-527. At 9:23 hours, firing position achieved on 2 destroyers. At 9:25 hours, 4 magnetic torpedoes launched. At 9:27 hours and 14 seconds, 0 detonations. All 4 torpedoes passed harmlessly beneath destroyer hulls. At 9:28 hours, Hartwig fired 3 contact torpedoes. At 9:29 hours and 37 seconds, USS Bristol struck forward. Kill time, 5 seconds. At 9:29 hours and 49 seconds, HMS Polyanthus struck amidships. Kill time, 6 seconds. At 9:30 hours, both destroyers began sinking. At 9:32 hours, 4 remaining destroyers converged. At 9:34 hours, U-527 detected by sonar. At 9:37 hours, first depth charge pattern. At 9:39 hours, second pattern forced emergency surface. At 9:40 hours and 23 seconds, destroyer gunfire struck U-527's conning tower. At 9:41 hours and 7 seconds, U-527 sank. Elapsed time from engagement to sinking, 18 minutes 7 seconds. Total engagement duration, 18 minutes 7 seconds. Enemy losses, 2 destroyers, 447 crew. German losses, 1 submarine, 47 crew, 7 torpedoes expended. Kill ratio, 2, 1 destroyers favoring Americans when accounting for submarine loss. The ammunition expended exceeded U-527's normal allocation for 7 separate attacks. The mathematics favored American production capacity. Weber observed the engagement statistics accumulating at Kiel headquarters. In July 1943, German submarines expended 312 magnetic torpedoes against American destroyers. Successful detonations, 47. Success rate, 15%. Contact torpedoes expended, 247. Successful detonations, 189. Success rate, 76%. The data proved American degaussing effectiveness. The mathematics were irrefutable. August 15, 1943, North Atlantic, 18:47 hours. 43 German submarines attacked convoy ON-202. The convoy included 21 merchant vessels and 14 destroyer escorts. The engagement lasted 7 hours and 34 minutes. At 18:47 hours, first submarine Wolfpack elements achieved attack positions. At 18:53 hours, coordinated magnetic torpedo launch from 7 submarines targeting 8 destroyers. At 18:56 hours and 12 seconds, 0 magnetic detonations occurred. All 17 magnetic torpedoes passed harmlessly beneath destroyer hulls. At 18:58 hours, submarines switched to contact detonators. At 19:01 hours and 47 seconds, USS Eldridge struck amidships by contact torpedo. Kill time, 5 seconds. At 19:03 hours and 19 seconds, HMS Itchen struck forward by contact torpedo. Kill time, 7 seconds. At 19:06 hours and 31 seconds, USS Holder struck aft by contact torpedo. Kill time, 6 seconds. Average kill time per successful attack, 6 seconds. At 19:10 hours, destroyer escorts converged on submarine positions. At 19:14 hours, U-134 detected by sonar and engaged with depth charges. At 19:17 hours, U-134 forced to surface after hull breaches. At 19:18 hours and 43 seconds, U-134 sunk by destroyer gunfire. At 19:22 hours, U-415 detected and depth charged. At 19:27 hours and 18 seconds, U-415 sunk after catastrophic hull failure. At 19:35 hours, U-732 detected. At 1938 hours and 52 seconds, U-732 sunk by coordinated depth charge attack. At 1955 hours, U-257 detected. At 2001 hours and 12 seconds, U-257 sunk. At 2018 hours, U-634 detected. At 2024 hours and 37 seconds, U-634 sunk. At 2047 hours, U-281 detected. At 2053 hours and 9 seconds, U-281 sunk. At 21:19 hours, U-445 detected. At 21:26 hours and 44 seconds, U-445 sunk. At 22:01 hours, U-608 detected. At 22:09 hours and 22 seconds, U-608 sunk. Total engagement duration, 7 hours, 34 minutes. Enemy aircraft destroyed, 0. American losses, 3 destroyers, 741 crew. German losses, 8 submarines, 384 crew. Kill ratio, 3:8 favoring American forces. The ammunition expended by American destroyers in this engagement exceeded German monthly allocation for the entire Atlantic submarine fleet. The fuel consumed by American vessels exceeded German weekly allocation for all surface operations. At 21:47 hours, Korvettenkapitän Hans Möller commanded U-517 during the engagement. His submarine achieved firing position on USS Davidson. At 21:48 hours and 33 seconds, Möller fired 2 magnetic torpedoes. Both failed to detonate. At 21:49 hours, he fired contact torpedo. At 21:50 hours and 18 seconds, torpedo struck USS Davidson, but detonation partially failed due to defective detonator. Destroyer suffered damage but remained operational. At 21:51 hours, USS Davidson and 2 escort destroyers converged on U-517's position. At 21:53 hours and 41 seconds, coordinated depth charge attack began. At 21:56 hours and 14 seconds, U-517's hull breached in 3 locations. Möller ordered emergency surface. At 21:57 hours and 38 seconds, U-517 surfaced within range of 3 destroyers. At 21:58 hours and 7 seconds, destroyer gunfire struck U-517's conning tower. Möller killed instantly by shell fragmentation. At 21:58 hours and 19 seconds, second salvo struck U-517's pressure hull. At 21:58 hours and 53 seconds, U-517 sank stern first. Elapsed time from engagement to death, 8 minutes 20 seconds. Weber observed the battle from U-boat headquarters operations room in Kiel. Radio reports came in continuous streams. Submarine after submarine reported magnetic detonation failures followed by contact kills, followed by detection and depth charging. The pattern repeated across all 43 submarines. American degaussing had neutralized Germany's primary weapon. American sonar had achieved detection superiority. American depth charges had achieved kill efficiency previously impossible. The mathematics transformed from favorable to catastrophic in 7 hours. The enemy's quote came from Fisher, one of the few submarine commanders who survived. Interrogated at a British prisoner facility in September 1943, he stated, "This wasn't combat. This was systematic annihilation. We fired our best weapons and they failed. We switched to contact torpedoes and succeeded occasionally. But their detection systems found us every time. Their depth charges were precisely calibrated. Their destroyers coordinated attacks with mechanical efficiency. We brought 19th century tactics to 20th century warfare." August 29, 1943, North Atlantic, 10:34 hours. U-373 engaged convoy HX-256 with 14 merchant vessels and 7 destroyer escorts. Korvettenkapitän Heinrich Schäfer commanded U-373 with 12 years' experience. At 10:34 hours, firing position achieved. At 10:36 hours, 5 magnetic torpedoes launched targeting 3 destroyers. At 10:38 hours and 47 seconds, 0 detonations occurred. At 10:39 hours, Schäfer fired 4 contact torpedoes. At 10:40 hours and 32 seconds, USS Bori struck forward. Kill time, 4 seconds. At 10:40 hours and 51 seconds, HMS Sunflower struck amidships. Kill time, 8 seconds. At 10:41 hours, both destroyers sinking. At 10:43 hours, 5 remaining destroyers converged. At 10:45 hours, U-373 detected. At 10:48 hours, depth charge pattern forced emergency surface. At 10:49 hours and 17 seconds, destroyer gunfire struck U-373. At 10:50 hours and 42 seconds, U-373 sank. Elapsed time from engagement to sinking, 16 minutes 42 seconds. Total engagement duration, 16 minutes 42 seconds. Enemy losses, 2 destroyers, 503 crew. German losses, 1 submarine, 51 crew, 9 torpedoes expended. Kill ratio, 2:1 destroyers favoring Americans. The ammunition expended exceeded U-373's normal allocation for 9 separate attacks. The mathematics remained catastrophic. August 29, 1943, North Atlantic, 10:34 hours. U-373 engaged convoy HX-256 with 14 merchant vessels and 7 destroyer escorts. Korvettenkapitän Heinrich Schäfer commanded U-373 with 12 years' experience. At 10:34 hours, firing position achieved. At 10:36 hours, 5 magnetic torpedoes launched targeting 3 destroyers. At 10:38 hours and 47 seconds, 0 detonations occurred. At 10:39 hours, Schäfer fired 4 contact torpedoes. At 10:40 hours and 32 seconds, USS Bori struck forward. Kill time, 4 seconds. At 10:40 hours and 51 seconds, HMS Sunflower struck amidships. Kill time, 8 seconds. At 10:41 hours, both destroyers sinking. At 10:43 hours, 5 remaining destroyers converged. At 10:45 hours, U-373 detected. At 10:48 hours, depth charge pattern forced emergency surface. At 10:49 hours and 17 seconds, destroyer gunfire struck U-373. At 10:50 hours and 42 seconds, U-373 sank. Elapsed time from engagement to sinking, 16 minutes 42 seconds. Total engagement duration, 16 minutes 42 seconds. Enemy losses, 2 destroyers, 503 crew. German losses, 1 submarine, 51 crew, 9 torpedoes expended. Kill ratio, 2:1 destroyers favoring Americans. The ammunition expended exceeded U-373's normal allocation for 9 separate attacks. The mathematics remained catastrophic. September 4, 1943, North Atlantic, 14:47 hours. U-641 engaged convoy HX-259 with 16 merchant vessels and 8 destroyer escorts. Kapitänleutnant Horst Dietrich commanded U-641 with 9 years submarine experience. At 14:47 hours, firing position achieved at 2,900 meters. At 14:49 hours, 4 magnetic torpedoes launched in spread pattern targeting 3 destroyers. At 14:51 hours and 31 seconds, 0 magnetic detonations occurred. All 4 torpedoes passed harmlessly beneath target hulls. At 14:52 hours, Dietrich fired 3 contact torpedoes. At 14:53 hours and 43 seconds, USS Herbert struck forward section. Elapsed time from engagement to destruction, 5 seconds. Kill time, 5 seconds. At 14:54 hours and 2 seconds, HMS Asphodel struck amidships. Elapsed time from engagement to destruction, 6 seconds. Kill time, 6 seconds. At 14:54 hours, both destroyers began sinking with visible magazine detonations. At 14:56 hours, 6 remaining destroyers converged on U-641's position using coordinated search patterns. At 14:58 hours, U-641 detected by sonar from 3 different destroyers simultaneously. At 15:01 hours, coordinated depth charge attack began with first pattern detonating at 160 meters. At 15:03 hours, second pattern detonated at 175 meters, 10 meters above U-641. Hull plates buckled under pressure. At 15:05 hours, third pattern detonated at 185 meters, forcing catastrophic damage. At 15:06 hours, Dietrich ordered emergency surface. At 15:07 hours and 29 seconds, U-641 surfaced within range of 4 destroyers. At 15:08 hours and 14 seconds, concentrated gunfire struck U-641's conning tower and pressure hull. At 15:09 hours and 47 seconds, U-641 sank stern first. Elapsed time from engagement to sinking, 22 minutes 47 seconds. Total engagement duration, 22 minutes 47 seconds. Enemy losses, 2 destroyers, 514 crew. German losses, 1 submarine, 49 crew, 7 torpedoes expended. Kill ratio, 2:1 destroyers favoring American forces when accounting for submarine loss. The ammunition expended in this engagement exceeded U-641's normal allocation for 7 separate attacks. The fuel consumed in evasive maneuvering exceeded U-641's daily allocation. The mathematics demonstrated American advantages in production, training, and coordination. September 11, 1943, North Atlantic, 8:23 hours. U-758 engaged convoy SC-143 with 11 merchant vessels and 5 destroyer escorts. Oberleutnant Kurt Brenner commanded U-758 with 7 years submarine experience. At 8:23 hours, firing position achieved. At 8:25 hours, 3 magnetic torpedoes launched. At 8:27 hours and 18 seconds, 0 detonations occurred despite optimal targeting. At 8:28 hours, Brenner fired 2 contact torpedoes. At 8:29 hours and 34 seconds, USS Leary struck aft. Kill time, 7 seconds. At 8:29 hours and 53 seconds, HMS Polyanthus struck forward. Kill time, 5 seconds. At 8:30 hours, both destroyers sinking rapidly. At 8:32 hours, 3 remaining destroyers converged. At 8:34 hours, U-758 detected by sonar. At 8:37 hours, depth charge attack forced hull damage. At 8:39 hours, Brenner ordered emergency surface. At 8:40 hours and 27 seconds, destroyer gunfire struck U-758's conning tower. At 8:41 hours and 53 seconds, U-758 sank bow first. Elapsed time from engagement to sinking, 18 minutes 53 seconds. Total engagement duration, 18 minutes 53 seconds. Enemy losses, 2 destroyers, 481 crew. German losses, 1 submarine, 46 crew, 5 torpedoes expended. Kill ratio, 2-1 destroyers favoring Americans. The ammunition expended exceeded U-758's normal allocation for 5 separate attacks. The pattern repeated consistently across all engagements. Magnetic torpedo failure followed by contact torpedo success, followed by submarine detection and destruction. Weber observed from Kiel headquarters as engagement reports accumulated throughout September 1943. 47 submarine attacks against convoys during September. Magnetic torpedo launches, 237. Magnetic detonations, 34. Success rate, 14%. Contact torpedo launches, 189. Contact detonations, 141. Success rate, 75%. Submarines lost, 23. Destroyers sunk, 37. Kill ratio, 1:6, 1 favoring Americans when accounting for submarine losses. The mathematics proved American degaussing effectiveness and production superiority combined with improved detection capabilities created insurmountable advantages. September 1943, London, England. Captain Lieutenant Friedrich Hartmann had been captured when U-882 sank in June 1943. British intelligence valued him for his technical knowledge and analytical capabilities. His interrogation testimony provided comprehensive assessment of Germany's perspective. We were not defeated by better soldiers, but by better factories. American degaussing production reached 247 systems daily from a single facility. German magnetic torpedo production reached 6 daily from all facilities. A single American factory produced more countermeasure systems in 1 week than our entire Navy could deploy magnetic torpedoes in 2 months. The production differential was 41-1. We could not overcome that mathematics. The degaussing system itself represented elegant engineering. Copper cables wound around the hull in precise configurations. Electrical current flowing through cables generated countermagnetic field. The field precisely canceled the destroyer's natural magnetic signature. Our magnetic influence detonators detected nothing. The torpedoes passed beneath hulls thinking they traveled through empty ocean. The Americans didn't just build better weapons. They revolutionized defensive systems faster than we could adapt offensive systems. American industrial capacity exceeded our comprehension. Their workers consumed more beef in cafeterias than our sailors received in rations. They discarded more copper cable from quality control than we allocated for research. They threw away more aluminum scrap than we allocated for production. Their abundance was absolute. Our scarcity was absolute. No tactical brilliance could overcome that fundamental disparity. Additional testimonies from captured German naval personnel revealed consistent themes. Fregattenkapitän Joseph Schroeder, captured after U-229 sank in August 1943. We brought swords to a gunfight, except the Americans brought factory-produced machine guns. They could lose 3 destroyers and replace them in 2 weeks. We could lose 1 submarine and replacement took 4 months. Oberleutnant Hans Weber, captured after U-744 sank in September 1943. Their excess capacity exceeded our maximum effort. A single American shipyard produced more destroyers monthly than our entire submarine fleet could theoretically sink. They built faster than we could destroy. The mathematics were hopeless. Captain Lieutenant Ernst Fischer, captured after U-386 sank in July 1943. They could lose 1,000 destroyers and build replacements in 6 months. We could lose 50 submarines and replacement took 2 years. Every engagement favored their production advantage. Time was their weapon. We had no defense against time. Oberleutnant Karl Schmidt, captured after U-441 sank in August 1943. The degaussing cables made our magnetic torpedoes worthless. We expended 4 or 5 torpedoes to achieve 1 kill instead of 1 torpedo per kill. Our ammunition capacity decreased by 75%. The Americans neutralized our technological advantage through mass production of countermeasures. Captain Lieutenant Werner Hoffmann, captured after U-592 sank in September 1943. American destroyer crews improved continuously. Their sonar detection accuracy increased. Their depth charge patterns became more precise. Their multi-destroyer coordination became mechanical. They learned faster than we could adapt. Their training infrastructure exceeded ours completely. The mathematics were presented in formal testimony. Korvettenkapitän Klaus Hartmann provided production statistics to British interrogators. American production of degaussing systems, 7,410 monthly by mid-1943. German production of magnetic torpedoes, 180 monthly. Single American factory production, 7,410 monthly. Entire German industry, 180 monthly. The ratio was 41:1. American production of replacement destroyers, 47 monthly. German production of replacement submarines, 4 monthly. The ratio was 12:1. American aluminum production, 920,000 tons annually. German aluminum production, 234,000 tons annually. American copper production, 1,240,000 tons annually. German copper production, 147,000 tons annually. American steel production, 89 million tons annually. German steel production, 21 million tons annually. Every material advantage favored America by factors of 4 to 8. We could not win a production war. The degaussing system cost approximately $47,000 per destroyer installation. America spent $3.2 million monthly on degaussing protection. This single defensive system consumed more resources than our entire magnetic torpedo research and production budget. They spent more money protecting destroyers than we spent building submarines. The economic disparity mirrored the production disparity. Weber provided tactical assessment from a survivor's perspective. American destroyer crews improved throughout 1943. Initial engagements showed uncertain responses to submarine attacks. By August, their coordination was mechanical. Sonar detection, depth charge patterns, multi-destroyer cooperation, everything improved. They learned faster than we adapted. Their training infrastructure exceeded ours. They could lose experienced crews and replace them with trained crews within weeks. We lost experienced crews, and replacement crews lacked experience. Fischer provided the final assessment that captured Germany's strategic failure. We assumed American democracy was weak. We assumed their diverse population couldn't coordinate industrial production. We assumed their preference for peace meant inability to wage war. Every assumption was catastrophically wrong. Their democracy enabled rapid industrial mobilization. Their diverse population provided unlimited labor. Their preference for peace made their war production more terrible because they built with the goal of ending the war through overwhelming material advantage. Schroeder provided additional analysis. The degaussing system represented American industrial philosophy. Germany focused on building sophisticated magnetic torpedoes. America focused on mass-producing countermeasures. Germany prioritized weapon quality. America prioritized defensive quantity. We built submarines individually with artisan craftsmanship. They built destroyers on assembly lines with interchangeable parts. We rationed copper by the kilogram. They discarded copper scrap by the ton. The strategic approaches diverged fundamentally. Schmidt described the psychological impact. German submariners who knew their torpedoes might fail lost confidence. American destroyer crews who knew their degaussing protection maintained morale. The mathematics of production created mathematics of psychology. Confidence came from abundance. Desperation came from scarcity. Warfare became as much about industrial capacity as tactical skill. Hoffman summarized the final lesson. We learned that dismissing democratic nations as weak because they prefer peace invites catastrophic miscalculation. We learned that underestimating free people's productive capacity when mobilized guarantees defeat. We learned that industrial capacity determines modern warfare more than tactical brilliance. We learned these lessons in blood. 41,000 German naval personnel died because we failed to understand these principles in March 1943. Oberleutnant Gustav Richter, captured after U-247 sank in October 1943, provided additional perspective on tactical evolution. American destroyer tactics improved systematically throughout 1943. In May, single destroyers responded to submarine attacks. By August, coordinated multi-destroyer responses became standard. Sonar detection accuracy increased from approximately 40% to 78%. Depth charge patterns evolved from random distribution to calculated geometric patterns based on submarine evasion capabilities. Their learning curve exceeded ours. Their training infrastructure allowed rapid dissemination of tactical improvements across the entire fleet. We lacked equivalent systems for knowledge transfer. Captain Lieutenant Franz Müller, captured after U-338 sank in September 1943, described the psychological impact on submarine crews. When magnetic torpedoes worked 90% of the time, submarine crews felt confident. When success rate dropped to 15%, confidence collapsed. Submariners knew that failed magnetic attacks wasted ammunition and revealed their position. Every magnetic torpedo failure increased likelihood of detection and death. The psychological burden of unreliable weapons exceeded the tactical burden. Crews lost faith in their primary weapon system. Morale deteriorated faster than tactical capability. Fregattenkapitän Ludwig Wagner, captured after U-453 sank in August 1943, analyzed the production implications. American degaussing production created geometric advantages. They produced 247 systems daily. We sank perhaps 3 destroyers daily across all theaters. They installed degaussing systems faster than we could destroy destroyers. The protection spread across their entire fleet within 9 months. Every destroyer we encountered after June 1943 had degaussing protection. The window of magnetic torpedo effectiveness closed permanently. Our sophisticated weapon became obsolete not through technical counter-innovation, but through mass production of countermeasures. Korvettenkapitän Otto Becker, captured after U-619 sank in October 1943, described the economic dimensions. The economic disparity exceeded our comprehension. America's entire military budget exceeded Germany's gross domestic product. They allocated more resources to destroyer protection than we allocated to submarine construction. The degaussing program represented a footnote in their military budget, but exceeded our primary weapon research program. They could afford to fail at 3 different countermeasure approaches and still succeed. We could afford to pursue one approach successfully. Economic capacity determines strategic options. Captain Lieutenant Heinrich Vogel, captured after U-371 sank in September 1943, provided the final assessment of German strategic failure. We assumed technological sophistication would overcome industrial capacity. Our magnetic torpedoes represented advanced technology. Their degaussing cables represented simple engineering mass-produced. Simple engineering mass-produced defeated advanced technology produced in small quantities. We learned that wars are won by factories, not laboratories. Scientific advancement matters less than production capacity. The Americans understood this principle. We did not. That understanding cost us the war. Production comparison analysis from captured documents. German intelligence documents captured in November 1943 provided comprehensive comparison of production capabilities. The documents revealed systematic analysis that German command had ignored. American degaussing cable production, 7,410 complete systems monthly. German magnetic torpedo production, 180 units monthly. Ratio, 41:1 favoring American defensive capacity. American destroyer production, 47 units monthly. German submarine production, 4 units monthly. Ratio, 12:1 favoring American replacement capacity. American copper production, 103,000 tons monthly. German copper production, 12,250 tons monthly. Ratio, 8:1 favoring American material capacity. American aluminum production, 77,000 tons monthly. German aluminum production, 19,500 tons monthly. Ratio, 3:1 favoring American material capacity. American steel production, 7,400,000 tons monthly. German steel production, 1,750,000 tons monthly. Ratio, 4:1 favoring American material capacity. American electrical power generation, 24,000 megawatt-hours monthly. German electrical power generation, 8,400 megawatt-hours monthly. Ratio, 2:1 favoring American industrial capacity. The production ratios explain strategic outcomes. American capacity to produce countermeasures exceeded German capacity to produce weapons by factors of 3 to 41, depending on specific systems. American capacity to replace losses exceeded German capacity by factors of 4 to 12, depending on vessel types. American material availability exceeded German availability by factors of 3 to 8, depending on specific materials. The mathematics were absolute. Industrial capacity determined strategic outcomes. Germany could not win a production war against America. The degaussing system proved this principle definitively. March 12, 1943. Kiel Naval Base, Germany. November 8, 1945. The degaussing system proved that free labor and democratic cooperation produced superior results to authoritarian command structures. Free workers outproduced enslaved labor because they had personal stake in victory. Democratic cooperation exceeded totalitarian command because it enabled innovation at every level rather than just top-down directives. Industrial abundance buried ideological superiority under 10 million tons of steel, 700,000 tons of copper, and 2 million miles of electrical cable. The lesson extended beyond World War II into permanent strategic doctrine. American industrial capacity, when fully mobilized, exceeded all other nations combined. A single American factory produced more in 1 month than some entire national industries produced in 1 year. This capacity stemmed from systematic advantages: abundant natural resources, advanced transportation infrastructure, educated workforce, innovative engineering culture, an economic system that rewarded efficiency. The degaussing system represented a single example of systematic American advantage. While Germany focused on sophisticated magnetic torpedoes, America focused on mass-producing countermeasures. While Germany built submarines individually with artisan craftsmanship, America built destroyers on assembly lines with interchangeable parts. While Germany rationed copper by the kilogram, America discarded copper scrap by the ton. The strategic approaches diverged fundamentally. The psychological dimension mattered as much as material dimension. German submariners who knew their torpedoes might fail lost confidence. American destroyer crews who knew their degaussing protection worked maintained morale. The mathematics of production created mathematics of psychology. Confidence came from abundance. Desperation came from scarcity. Warfare became as much about industrial capacity as tactical skill. The philosophical lesson remains relevant. Democracies that prefer peace should never be mistaken for democracies incapable of war. Industrial nations that waste resources in peacetime reveal capacity to produce resources in wartime. Free peoples who seem disorganized in peace can organize with terrifying efficiency in war. These patterns repeat across history because they reflect fundamental advantages of democratic industrial systems. March 12, 1943, Korvettenkapitän Hans Möller had laughed at American degaussing systems. He called them desperate improvisation. He dismissed them as ineffective decoration. September 15, 1943, Möller died when his submarine was sunk by the destroyers his torpedoes could no longer destroy. His mockery became history's most expensive miscalculation, measured in 41,000 German naval personnel killed and 783 submarines sunk. The lesson remains: dismissing democratic nations as weak because they prefer peace or underestimating free people's productive capacity when mobilized invites catastrophic miscalculation. Industrial capacity determines modern warfare more than tactical brilliance. Abundance defeats scarcity. Democracy mobilized defeats authoritarianism always, because free peoples produce more than enslaved peoples, because voluntary cooperation exceeds forced compliance, because innovation throughout society exceeds innovation from central command. The mathematics were and remain absolute.